Thanks, Seth, for the introduction. So, yeah, I'm Peter Clark. I manage the Aristo project at the Allen Institute for AI. And as Seth said, I'm here with Oivind Taffert, who's a principal research scientist at AI2, and he's the main creator of Macaw, which is the system that I'm going to talk about. To Seth, thank you so much for inviting us. It's an honor to be here and to be able to talk about some of the work we're doing. I'm going to present our work on building a new state-of-the-art question answering system called Macaw. First, though, for those of you who don't know about AI2, let me just give a brief summary. So AI2 was founded in 2014 by the late Paul Allen, the co-founder of Microsoft. And it's a not-for-profit research institution. So it's dedicated to essentially scientific philanthropy. Its mission is AI for the common good. How can humankind benefit from the immense potential of new technology? And we've become a leading group in computer vision, natural language processing, and deep learning. We've got now about 150 researchers, engineers, and support staff. And we're hiring. So if you're looking for an exciting new job, please let me know. We're always interested in recruiting new talent. And then just briefly about the organization within AI2, we have 6 main research groups. There's the Aristo group, which is the group I manage, which is devoted to question answering and machine reasoning. We have a project called Mosaic, which is studying the use of common sense knowledge in AI. We have Allen NLP, of course, which is the NLP group, and they created the Allen NLP platform for NLP research, which some of you may know about. We have a team called Prior, which is the computer vision team and perception. So looking at integrating vision and perception, including in robotic environments. We have Semantic Scholar, which is devoted to the smart handling of technical documents and associated media. So think of Semantic Scholar as the smart version of Google Scholar. And then finally, we have an incubator, which is fostering new startups for AI applications which have a common good motivation. So that's a kind of overview of our structure as an organization. For those of you who don't know, we're based in Seattle. So here's a picture of Seattle on one of the nicer days in the summer, looking over Lake Washington and Lake Union. This building here is the AI2 offices. So if you're in Seattle, come drop in and see us. The last 2 years, of course, with the pandemic, I've actually spent most of my time more at home than in the offices. So this is more what my setup looks like, a not particularly well-lit basement. This is where I am at the moment. So that's just so you have a visual of where I'm speaking from. So let me just tell you briefly about the Aristo project as well. So the Aristo project was the first project at AI2, and our original mission was getting computers to reason about science, which is a super challenging task. The name Aristo is a play on Aristotle as a child, as we initially were looking at having the computer answer elementary level science questions. And the way we were measuring progress on Aristo was to test our software on real science exams. So a typical question we would give Aristo would be this question: how are the particles in a block of iron affected when the block is melted? Particles move more rapidly. This turns out to be a very complex question to answer. We need both science knowledge about how temperatures affect particle movements, and then just common sense knowledge that if you melt something, its temperature must have increased. So we worked away on that for 5 years, and finally, after 5 years of work, with a large assist for new technologies, we finally scored an A on the Regents 8th grade multiple choice science exams. So that was a huge achievement for us. It made the headlines in the New York Times business section. But it also left this nagging question about, does the system really understand the underlying science, or is it just guessing very cleverly? So our new work in Aristo since then has moved on to focus on reasoning and explanation, which is what we're studying now. And we've been pushing in 4 key areas. The first is, how can we just generally improve question answering? And that's what I'm primarily going to talk about today with the Macaw system. But I'll just mention the other areas where we're pushing on as well. The second is, how can we get language models to perform deductive reasoning using rules written in natural language? So we have a system called Rule Taker, which will attempt to do that. And then thirdly, more recently, can we get language models to perform more human-like reasoning using both rules that we give it and the internal knowledge which is stored inside the neural net itself? Super exciting area that we're working on now. And then finally, can we give a persistent memory to a neural system to ensure that these neural systems spot and correct incorrect answers that they, or inconsistent answers that they may otherwise give to users? So these are the 4 areas that we're pushing on. Anyway, for today, I'm going to focus mainly on the Macaw system, which has turned out to be quite a remarkable question answering system that we've been developing. So as a brief outline of what I'll cover, and just to Seth's comment at the beginning, feel free to ask questions or raise your hands as I go along. I'm quite happy to take interruptions and questions. I'm going to talk about what Macaw does, how it was built, summary of how good it is, and also show you some interesting cases where it breaks. Talk briefly about what's next, and then for those of you who are interested in actually getting your hands on this and using it, give some pointers to how you can do that. So first of all, Macaw and the history of question answering systems. I'll just give a very quick trajectory of how question answering has developed over the decades. So in the early days of AI, QA systems were simple, hand-built, specialized tools like the Lunar system mentioned here could answer a few questions about rock samples obtained from the moon. It was built using a bunch of hand-coded rules. And then in the 1990s, there was the expert systems revolution in AI, where people realized there should be a clearer separation between the knowledge about the world that these systems had and the rules needed to reason with that knowledge. And various systems, again, hand-built, were created, like Prospector, for instance, which helped with oil exploration. And then from 2000 onwards, with the mass availability of online text, corpus-based question answering methods came to the fore, where answers could be found in text rather than computed using handwritten rules. IBM's Watson system that won Jeopardy is probably the best example of that. And then, of course, with the recent deep learning revolution, neural QA systems now completely dominate. The earlier neural systems would work typically with a corpus of text, and they would be trained for a specific task, for example, answering questions about Wikipedia articles. And then now today, we have pre-trained language models where a vast amount of textual knowledge has already been built into the network already. So they no longer have to go out and read a passage in order to find answers to questions, although they can be trained to do that. Rather, they can leverage what they already have in their pre-training phase. And that gives them remarkable power, as I'll show in a second. I mentioned GPT-3 here as an example of one of these systems. The asterisk here is just to note that GPT-3 is not specifically a question answering system. Rather, it's a general purpose system that can do many things, including question answering. And that's in contrast to Macaw, our system here, where we've customized it to be extremely good at question answering in particular. So Macaw is a state-of-the-art question answering system. It's built on top of the T5 transformer model. And it gets a lot of its skill through the massive training, as I'll describe in a minute. But first, I just wanted to show you some examples of some of the remarkable answers that Macaw can give. So for instance, if I ask it this question, how would you make a house conduct electricity? Macaw comes up with this quite impressive answer: paint it with a metal paint. If I ask, what is an implication of a cat being an animal? So this is kind of a meta question. System comes back with a good answer. It is feelings. If I ask it, could a newborn look over the top of a fully grown horseradish plant? It comes back and says no, because the plant is so tall. So that gives a hint, at least, that it may be doing some kind of spatial reasoning. If I ask it, why couldn't Aristotle have used a cell phone? System comes back and said he was born before cell phones. And then perhaps the most impressive example is this question. So this is a riddle, which many of you may be familiar with. So it goes, a young boy was rushed to the hospital emergency room, but the ER doctor saw the boy and refused to operate. This boy is my son, the doctor said, but the doctor wasn't the boy's father. How could this be? So those of you who have seen this riddle before know the traditional answer to this is that the doctor is the boy's mother. Macaw actually comes back with a different answer, but a completely reasonable one. It says he mistook the boy for his own son. And the reason this is kind of striking and remarkable is, in order to generate this answer, the system really has to have at least some degree of understanding about what is quite a complex situation going on with relatives and family relationships in the ER room and so on. So this is quite surprising. And all these examples as well should show you that the system is not just question answering by retrieving answers from text that it read in its pre-training. It's also able to combine information together in novel ways, in slightly mysterious ways in its internal parameters. So, so how is Macaw? Why is Macaw called Macaw? So Macaw stands for multi-angle question answering, and by that we mean that we can switch the inputs and outputs, which we call angles, to give different behaviors. And so just to illustrate that, if I ask, what gas do producers produce that consumers need to survive? So I give it a question and ask for an answer. It gives me a good answer, oxygen. I can give it a question and ask for both an answer and an explanation. So here I ask which forces pull objects to the ground. It tells me gravity. And it tells me as an explanation, gravitational force causes objects that have mass to pull down on the planet. I can give it an answer and ask it to produce a question and explanation. So I give it the answer elephant, and it generates a question, which animals has the largest ears, and gives an explanation, the ears of an elephant are the largest. I can give it an answer and ask it to give me a question and a set of multiple choice options. So here Macaw generates the question, which of these items is necessary for a car to start? And it generates multiple choice options: car battery, windshield wiper blade, car radio antenna. Or I can give it an explanation, like the leaves of a plant convert sunlight into food for the plant, and ask it to give me both a question and an answer. And it generates how do plants get energy with the answer from the sun. So this gives an example of the kind of versatility that's also present in Macaw by virtue of the way that we've trained it, where we can permute these inputs and outputs and get these different behaviors. So how is Macaw built? Well, Macaw is built on top of Google's T5 pre-trained language model. So T5 itself is a large neural system that uses the transformer architecture. And T5 is pre-trained to predict hidden or masked words in text. So which text was T5 trained on? Well, Google first took a vast crawl of the web called Common Crawl. It's illustrated here. It's about 200 terabytes. They then filtered it down to just regular English text that produced still about 3/4 of a terabyte of text. And then what they did was they took passages, masked out words, and then they trained T5 to predict those masked out words, rewarding the network when it made the right predictions and penalizing it when it was wrong. So for example, given this sentence here, drawn from this corpus, thank you for inviting me to your party last week, they would mask out for inviting and last and give T5, thank you, blank, me to your party blank week, and it would be expected to predict blank for inviting blank last to fill in the blanks here. And as I say, the reward function allows the system to fine-tune its parameters until it gets extremely good at doing this. This is the way T5 is trained. What we then do is then train it further on a collection of 300,000 question answering pairs. This is a list of the different data sets that we use to cull these 300,000 question pairs from. And the result of this means that the system is then highly customized for answering question answering here. And let me just pause for a second. There's a question which came up in the chat, which is a great one. Did you fine-tune Macaw with your own corpus to answer specific questions about the content? So this is a great question. These training data sets we've given it span a whole variety of different genres of text. So no, we haven't trained it for a specific domain or a specific genre of text. Rather, we've covered a whole variety of text and also a whole variety of different answer formats. One of the insights in building Macaw is we can take not just different domains, but different question answering formats to train the system further. And I'll just illustrate this here. So one style of question, which is quite common, is reading comprehension questions. So here's an example here. I give you a passage. I ask, at what speed did the turbine operate? And the answer should be 16,000 RPM. This answer is an extractive answer in that it's contained in this passage I gave it. Another style of question is abstractive questions, where I give a passage, I ask a question. What does a drink from Narcissus's spring cause the drinker to do? And here the desired answer is fall in love with themselves. This is an answer that's not explicitly stated in the passage, rather it's something which is a generated summary of what's been given. Third style of question is, what does photosynthesis produce that helps plants to grow? And we give it multiple choice options. Here there's no text to get the answer from. Rather, the system is expected to produce its answer from all that knowledge is acquired during the original pre-training of T5. And then the fourth style of question is true-false questions. Like this example here, was America the first country to have a president? The answer is no. And so one of the insights here that we borrowed from an earlier system that AI2 built called Unified QA is that we can take many questions with different answer formats and put them into the same system and end up with a vast amount of training. And this causes Macaw to be very good at question answering. And then, of course, I mentioned that we have this multi-angle behavior. So to train that, we can take these question and answer pairs and then permute them. So instead of giving a question and generating an answer, we also give it the answer and the input passage. And now we want Macaw to generate a question, as I illustrated earlier. Similarly, we can permute the answers in another way, where we give a passage, and now we want Macaw to generate both a question and an answer, as illustrated here. So these are all different ways we train the system, and this is what gives Macaw the versatility that we observe. So that's how Macaw is trained. We do one last step of training, which is to train further still on a special data set called ArcDA. So this is a data set which includes both a direct answer question, which has to be generated, and explanation fields. So an example of a question in this data set is this one. What is an example of a non-renewable resource? The answer, petroleum. And the explanation is petroleum is kind of fossil fuel. Fossil fuels are a non-renewable resource. And this extra step of training, although it's a small number of examples, turns out to be quite significant. It allows Macaw to be very good at generating answers, and it also teaches it to generate explanations with some degree of reliability of the form that's generated there. And so there's a question. Let me just grab another question off the chat here. How large can the context passage be? Tokens, characters, or words as appropriate. Macaw uses the 512 token limit of T5. So as reading a passage, if we wanted to feed the whole passage in, it would have to be restricted to be about 400 or 500 words. If we wanted a longer amount of text, for instance, we wanted to answer questions related to Wikipedia, we would need to add a retrieval component on the front to retrieve relevant text, and that could be and that would allow it to deal with a larger amount of text. I'm just going to read another question as well. This is Grace. I encourage you to ask these questions. Could Macaw assert the truth of a statement, possibly non-trivial? Well, Macaw answers questions, so it's asserting. Macaw is describing its belief in the truth of a statement, and some of the statements can be non-trivial. We can assert a statement to Macaw, so we can tell it something is true, and then ask a question. So we can say, metals conduct electricity, so would a knife conduct electricity? And Macaw will answer questions like that. And I'll mention in another example, we can actually assert something that's false. So I can say, metals do not conduct electricity. Would a knife conduct electricity? And Macaw is generally pretty reliable at then following my counterfactual statements, and in that case saying no. So it will do all those things, and I'll demonstrate some of those capabilities in just a section, in just a second. So anyway, all of this leads to Macaw. That was how is it built. So how good is it? Where does it break? And so on. So Macaw has generally near state-of-the-art zero-shot performance on several existing data sets. So here on the ARC data set is given a rather cryptic name at the top here. Macaw was at the top of the leaderboard, at least till recently. And I should just reinforce these are zero-shot performances. So this is without further fine-tuning the system on a particular data set. We simply give it the questions and see how well it does. To probe it more carefully, though, we created a challenge data set of 300 questions by repeatedly trying to break the system and recording all the results. So we tried to be as varied as possible when kicking Macaw's tires, or should I say, stretching Macaw's wings. And then we grouped the questions according to 22 different categories, so we could see which categories of questions were most problematic for Macaw. So just to show some of these example categories, common sense, for instance, if I put some cheese in the fridge, will it melt? Comparison questions, for example, how do pandas and parrots differ? Entity tracking, so this turns out to be a difficult challenge. My house is red, I painted my house white, what color is my house now? All story understanding questions, I crashed my car. When I finally left the hospital, all I wanted to do was sleep. I had to call a taxi. Why was I in hospital? And then there's 18 other categories. So we built this data set to try and both probe where Macaw does well and where Macaw does badly. First of all, I'll show you some categories where Macaw does well. So one category it does fairly well on is entity substitution. So this is where I ask it for alternative entities to perform a task. So I'll show you some examples here of Macaw's answers. So if I ask it the question, James went camping in the woods, but forgot to bring a hammer to bang the tent pegs in. What else might he use? Macaw gives a good answer of using rocks. And just for interest, GPT-3, when we gave this to GPT-3, it said his head, which is not such a good answer for this particular question. Mary wants to heat up some water, but a stove is broken. What else might she use instead to heat the water? Macaw says a campfire. So again, this is a good answer. Again, requiring some degree of understanding of the situation. Second category, which to my comments earlier, is dealing with hypotheticals. If I ask it this question, if plastic was a conductor, then would a plastic spoon conduct electricity? Macaw correctly says yes. And just to test, it's not a lucky guess. If I give it the opposite, if plastic was an insulator, which of course it is, then would a plastic spoon conduct electricity? Macaw says no. If a bird didn't have wings, how would it be affected? Macaw correctly says it would be unable to fly. So again, it's providing some interesting answers here. Macaw will do reasonably well on these meta-reasoning questions. What's an implication of a cat being an animal? It has feelings. I've asked it this slightly tricky question, what is an incorrect implication of a cat being an animal? Macaw correctly answers, it is a human. So again, that's showing some sophistication in understanding the logic of the question that's being asked here. And again, just for contrast, GPT-3 tells us an incorrect answer that it's an animal. And then finally, Macaw will handle to some degree false presuppositions. So these are questions where they're essentially trick questions, which assumes something that is false. So if I ask what year did Tom Hanks land on the moon, Macaw correctly says no year. GPT-3 in contrast says Apollo 13, 1995, obviously getting confused with the movie. But Macaw struggles with this question. How old was Mark Zuckerberg when he founded Google? Macaw incorrectly here says 17. Of course, the answer should be he didn't found Google. So I'm just going to glance at the chat here because there's some interesting questions that come up here. Does Macaw provide the n best answers to a question? It will, by default, it will produce just the best answer. We can change the way it samples answers to produce a alternative answers. So we can do alternative decoding methods such as nuclear sampling to sample alternative answers. And so, yes, we can generate an alternative collection of answers if it's desired. And then another question here, these are great questions. How effective would Macaw be if the training data set is small structured data, such as cybersecurity related facts and rules? So Macaw technically doesn't need any, Macaw comes already pre-trained, so it technically doesn't need any training data to answer new questions. It can be further fine-tuned on training data. It is not, I actually don't know how well it would perform given structured training data such as structured rules. That would be an interesting test to see whether it could take a set of rules as input and see if it could then answer questions on those. So I don't know specifically on that. And then another great question here, is Macaw able to return some sort of metric about how confident it is with its response? Macaw returns a score associated with its answers. So these can loosely be taken as a confidence measure. What we found is these scores tend to be highly skewed. So the scores will almost always be very close to 1, or very confident, or very close to 0, being very unconfident. They do loosely correlate, or at least the ordering is loosely correlated with degree of reliability. But as I say, the skew is pretty strong. So a score of 0.999 would be very good. A score of 0.991 would be considerably less confident in the answer, although the numbers although the numbers quite strong. And another question here, can Macaw be repurposed for other NLP tasks besides question answering? It's really designed for question answering tasks, but of course question answering is a very wide category of tasks, and in fact many tasks can be coerced into question answering. If you really wanted to do a different task, for instance, I don't know, code generation or something like that. So that's not really what Macaw is designed for. If you wanted to do a task like sentiment analysis, that of course can be coerced into a QA task. So I could give a movie review and ask a question, you know, is this a positive or negative review? Certainly Macaw could be easily coerced to perform that sort of task. So these are examples here of categories Macaw does well on. Let me just show you, which is quite interesting, some categories where Macaw does not so well on. So one category which is interesting is where a system has to track changes of the world over time, so-called entity tracking problems. So let me give you some examples here. So consider this question. Imagine an empty cup. Now I put a coin in the cup. Now I'll take the coin out of the cup. How many coins are in the cup now? Macaw incorrectly gives the answer 1. So you can see if you read this question, you mentally picture the world and how it's changing over time. It doesn't seem that Macaw or even other language models are particularly good at this. My house is red. I painted my house white. What color is my house now? Macaw correctly says white. My house is blue. I painted my house red. What color was my house before I painted it? Macaw correctly says blue, so that's good. My house is red. My neighbor's house is blue. I painted my house white. What color is my house now? And Macaw incorrectly says it's the same color as my neighbor's house, so it's got confused here. And finally, my house is red. I painted my neighbor's house white. What color is my house now? And Macaw incorrectly says half red and half white. So you can see here, this is showing that the system, although it may understand parts of the world, is not able to do the kind of mental simulation that that humans are able to do as they read these kind of story questions. The second thing Macaw struggles with, perhaps not surprisingly, is non-trivial arithmetic. Surprisingly, it will do simple arithmetic. What is 7 plus 5? It gets the correct answer 12. It'll do, with some degree of reliability, 2-digit addition. What is 25 plus 59? It'll say 84. But if I ask it, if I push it further, what is 241 plus 7864? It gives the incorrect answer 1, 2, 3, 4, 5. I mean, it's interesting to note here, although this is the wrong answer, first of all, it knows an answer is requested, and generally it gets the right order of magnitude. So it's got some vague sense about the answer, but it's clearly not doing systematic arithmetic in the way that people are able to do. And then finally, common sense reasoning. This turns out to be a very challenging task for many systems. So if I give it this question, if an electric car did not have any gas in it, how would it be affected? Sort of a trick question. Macaw incorrectly says it would not move. Sally's favorite cow died yesterday. When will the cow be alive again? Macaw incorrectly says in a few days. This is a little bit of a false presupposition question because the question is sort of implying it will be alive at some points, but Macaw should say it won't be alive again, but it gives that answer. And then this is another interesting question. You poured yourself a glass of cranberry juice, but then absentmindedly poured about a teaspoon of grape juice into it. You drink it. What happens next? Macaw incorrectly says you get sick. Just for contrast with GPT-3, which also answers incorrectly, GPT-3 says you'll probably die, so that's also not a great answer. So this shows that there are categories where it struggles. And just to mention, we've tried GPT-3 on these questions. GPT-3 does very well generally on these questions, but it struggles as well. So just to give you a few interesting examples of GPT-3 failures. Why do houses have windows? GPT-3, so you can throw the dog out, not really the purpose. What's the role of a carburetor in a car engine? GPT-3 tells us it's a device that converts water into gasoline. If only that were true. Why does speeding cause car accidents? Because you can't turn time into space, GPT-3 tells us. How would you make a marriage stronger? GPT-3 tells us I would make sure that I was the one who was always right. So again, GPT-3 not showing its marriage counseling strengths here. What are the steps involved in replacing a light bulb? GPT-3 kind of gets carried away. Make sure it's dark, reach up high, turn the bulb again, turn the bulb again, turn the bulb again, and so on. And finally, this one I liked. GPT-3 lists all the steps in planning a wedding. It tells us the first step is to get engaged, second step is to plan the wedding, third step is to get married, the fourth step is to have a baby, fifth step is to have another baby, the sixth step is to have another baby, the seventh step is to have another baby, and so on. So this is to show GPT-3, although good at these questions, is not great as well. It will fail at some points. And then finally, sorry, just to show one other example of an interesting sequence with Macaw. How would you make a table stronger? Macaw says add more supports, so that's a good answer. How would you make a rope stronger? Add strands, again, a good answer. How would you make a blanket stronger? Add layers, that's good. How would you make a marriage stronger? Repeating the question I just showed with GPT-3. Macaw insightfully says communicates, so that's a good answer. How would you make an investment stronger? Macaw's answer is diversify. How would you make a balloon stronger? Here it kind of gives a bad answer, add air. How would you make a window stronger? Double pane it. How would you make a contract stronger? Add more clauses. So you can see, although these questions are syntactically very similar, they're probing on very, very different aspects of world knowledge, and Macaw is generally being very reliable in its handling of these things. We've tested the system on these in depth on this Challenge 300 data set. This graph shows how 4 systems perform on our question categories. The blue bar here is Macaw. The red one is GPT-3. The green and purple are 2 recent QA systems from Google and AI21 labs, respectively. And as you see in the charts, Macaw is about 10% ahead on average of the other systems. The other really interesting thing here is these different question categories. So you see generally they're ordered from the highest average score to the lowest. You can see that generally these language models are very good at general knowledge questions and story understanding questions. They struggle most with these entity tracking, world simulation questions, common sense questions, and these false presupposition questions are particularly challenging for it. So I think what I'm going to do now, I'm going to switch to a live demo, and so there's a couple of questions which have come in on the chat. So let me, I'm going to stop my sharing, and I'm going to share, if I can find it, Macaw itself. So, oh no, sorry, I shared my PowerPoint version again. Just give me 1 second here. And I want to share this one. All right, this is it. So this is the live system. So I can ask question like what gas do plants give off, and I ask for the answer. This is a simple question. It tells me oxygen. Somebody asked, can it give explanation? So it will give answers. So let's just try this one and see what it says. So the answer is still oxygen. It says oxygen is a kind of gas at room temperature. It's true, it's not really quite relevant to the question. Then it does give me some good facts. Photosynthesis means green plants convert carbon dioxide, blah, 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 into oxygen. Plants are a source of oxygen. So that's a good explanation. It's worth mentioning here that this explanation is not necessarily what went on inside the neural system. Rather, it's trying to present facts in the style that it's seen in the training data in order to give its answer. Again, just to show its multi-angle capability, I can give it an answer like oxygen, and now ask it to generate a question about oxygen. Let's see what it does here. What do animals need in order to survive? I could do other questions. It doesn't have to be simple answer. Like say, list all the parts of a car and see what it gives me. And so I'm not sure why it's shown. So, oh, it's gone. I'm not sure why it's gone back to this old answer. List all the parts of a car. Answer. See what it's going to do here. So it's given a number of parts here: body, engine, tires, windshield wipers, tires, and its explanation here is not great. A car is made of many different parts. A wheel is part of a car, a tire is part of a car. So it's given some answers there. And I'm happy to try some questions from the audience here. So somebody at the beginning asked me to ask it, what's the least healthy item on the McDonald's menu? So let's try that one. I don't quite know what it'll do here. I'll ask it to give an explanation as well. French fries, it says. French fries kind of fast food. Fries usually have more fat than other fast food items. So that's kind of a reasonable answer to the question. Another question, can you ask it about the future? How will I feel tomorrow? Well, it doesn't know who I is, of course. I could ask it, who will win the next presidential election, for instance. Of course, who knows that? So, well, it says Trump. Its explanation is completely wrong here. The next presidential election is in 2016, so it's completely flawed in that reasoning there. And if I ask it, how will I feel tomorrow? How will I feel tomorrow? It doesn't know who I is. It's going to make a guess based on, everything it's seen in its pre-training, and see what it says. I will feel the same. And then it's giving a slightly garbage explanation here. Feelings are a kind of emotion. A feeling is a kind of state of being. If something is a stimulus, then that something will cause a response. So nothing that's really insightful here. So can you tell me a joke? That's an interesting one. I would imagine, tell me a joke. It may just say yes to this, but we'll see. Yes, jokes are punchlines. A punchline is a part of a joke. So I'm going to ask it to tell me a joke. Tell me a joke. And see what it says there. I'll take off the explanation because it's not really very good. Let's see what it says. Tell me a joke. What is an example of a joke? So I'm trying to coerce it into trying to be funny. Part sound well. Okay, so it's kind of its crude humor, and this is probably an appropriate point to point out. Macaw, because it's trained on the World Wide Web or a subset of it, like any language model, it's prone to, or it has the risk of producing, biased or obscene or offensive answers in its questions as well. So anybody who's doing question answering with language models should be sensitive to that. Let me. Okay, I'll just do a couple more examples as people want to try. Tell me a joke about 2 fleas and a dog. See if we can put that together. 1 flea, 1 dog. Okay, so it is clearly not responding properly to the notion of a joke. What is a joke? Hopefully it will give that as a funny story, so it knows that. Somebody Here's another example. Could you ask questions to recognize feelings? So that's a great question. So let's try this one. John has been crying all day. How does John feel? And let's ask it for an explanation as well. Sad. Crying is used for expressing sadness. Sad means feeling sad. So it seems to show some degree of awareness about emotions. A question: what is the GDP of? Well, there's two versions here. What is the GDP of What's the GDP of Tasmania? Let's see what it says about that. So 270 billion. And then the question that you asked was in Polish, in a different currency. Well, let's try in US dollars. And gosh, let's see if it even understands that. $2.8 billion. I actually don't know if that's right or not, but anyway, it's tried to do something with that. And then in Polish zloty. Let's get that. No, so here it's not even given a number here, so it's struggled there. Okay, and then so one last question was, why is Russia attacking Ukraine? So that's an interesting question. So the reason this is interesting is that Macaw doesn't have any access to the news. It's trained on the C4 datasets 2019, so it won't have any knowledge about recent events. So we'll see what it's doing. Again, it looks like its cache was, oh, and I misspelled Ukraine there. Let's see what it says now. To gain control of the region, that's a bit of a generic answer. Let's see if it gives an explanation here as well. Yeah, so Russia is attacking Ukraine to gain control of the region. I guess that's a generic answer about attacking. So that's another example. So I'll probably stop here. There'll be some time for questions at the end when I can do some more demos if people would like. But let me just finish off on the presentation, and then there's some other great questions which have come up in the chat window as well, which I'll point out. Just to mention, there's a online browser of Macaw's and GPT3's answers to our 300 questions. Just Google MCCOR AI2 if you want to browse those answers. You'll see both the good, the bad, and the ugly. And then finally, I just wanted to just briefly mention what's next and just give you a flavor of what our current projects are and where we're going with all this work. MCCOR is an impressive QA system, but it is still a black box. It can offer sort of an explanation as a sentence or two, but it's got no notion of a chain of reasoning inside. Sometimes it gives answers that imply it's done some sort of combination of facts that it knows about, but it's not really producing a sort of systematic chain of reasoning the way you or I might do when we answer a question. So one of our new projects is called Entailment Writer, where we're retraining a system, again, similar to MCCOR, but to not just give an answer, but to give an explanation which is a coherent chain of reasoning. For instance, if I ask, do plants require CO2 to make their own food? It'll produce an answer like this. Yes, plants require CO2 to make their own food because a plant requires CO2 for photosynthesis, and photosynthesis makes food for the plant. And the important thing here is these aren't just sentences that seem relevant to the question, but they form a sequential set of reasoning steps that support the answer that's given. So this is a super exciting new area that we're working on. Our goal here is to try and essentially open up the black box of a neural system so we can have more reasoned answers to allow the users to interact with the system. Secondly, we're working on a project called Belief Bank, where we're trying to generate consistent answers over time. So for instance, if you ask Macaw these questions, is oxygen colorless? Macaw will say yes. If I then ask what color is oxygen, it'll incorrectly tell me blue. What color gas do plants emit? In other words, oxygen. What color gas is that? It'll tell me green. So this is kind of frustrating. The system's given answers, but it's not aware of any of its internal self-contradictions. So our new work here is to take Macaw and add a layer of memory on top where it remembers the answers it's given to different questions, and have a layer on top which looks for contradictions. And if it spots them, to go ahead and work out the least cost way of resolving those contradictions. So we end up with a consistent set of beliefs sitting on top of the language model in its answers. And so this is, again, super exciting to us. It's looking at a cognitive architecture, which is more than just a neural system, but has a layer of memory on top. And then thirdly and finally, if we have systems that can reason systematically and explain their reasoning, and we have a layer of memory, and we have some degree of interaction, this all points the way towards teachable systems, namely systems where users can see a chain of reasoning, and if it's incorrect, interact with it to correct it. And so just to show you the style of dialogue that we're striving towards, if the user asks, can you pick a penny with a magnet? The system says yes, the user should be able to ask why. The system should then give a reasoned explanation for its answers, such as pennies are made of metal, metals are magnetic. Now this chain of reasoning is actually flawed. In fact, you can't pick up a penny with a magnet. And the user should be able to now argue back with the system and say, actually, not all metals are magnetic, copper is not magnetic, and then have the system try again. And then using this new information as part of the context for the question, the system can rethink its answer and generate an alternative answer. And here comes answer with the answer no, because pennies are made of copper, copper is not magnetic, and we get the right answer out. And so the way this extended architecture looks is we have entailment writer, trains roughly similar to Macaw, only with chains of reasoning explanations, plus we have a persistent memory. The user asks a question, the system retrieves some facts and uses those in conjunction with its pre-trained knowledge to generate an answer. This answer may be incorrect, so the user can give some feedback. As I showed, not all metals are magnetic, copper is not magnetic. This goes into its memory. We now re-ask the question, retrieve new information from this memory, and then in the ideal case, when it all works, we'll end up with a correct answer like pennies are made of copper, copper is not magnetic. And so that's a very quick overview of all the the directions we're going on. So what I'm going to do now is I will just finish off by briefly mentioning how you can get more Macaw and use it. I can then open up to further questions and address some of these great questions in the chat, and we can explore and I can answer additional questions. So getting and using Macaw, the easiest way of finding it on the web is Googling AI2 Macaw. We have a GitHub repository where Macaw is super easy to download and use. If you're familiar with the Hugging Face system and the library, you can use it here. What I'm going to do here is I'm just going to, again, I'm just going to switch to that GitHub repository just for people to see what is available here. And so this is the GitHub repository. There's information about how to use it. And just with a few simple commands, if you're familiar with Hugging Face, you can link in the model and ask it questions. And I think what I'll do is, let me just pause here and pass over to Oyvind. Oyvind, do you want to say anything more about how people might use it and its operation?
Yeah, hi. Yeah, thanks for all the interest here and good questions. So yeah, if you're interested in trying this yourself, it is, as Peter says, very easy to get. If you have used Hugging Face, the lines of code there are basically straight out of Hugging Face. It's referencing the Macaw large model, which is sort of the smallest of the models. It runs on the CPU. in a few seconds. It's not as strong as the 11 billion model, but it's good to sort of check that things are working. And as seen in that input string line there, it's a little bit cryptic, the input format. And so there is some helper functions in this repository. So if you download that, in the next section there, you can run it in a more user-friendly way. And that also shows you how you would load the larger model, the 11 billion model, onto, if you have, for instance, two GPUs that add, you have to have about 48 gigabytes or so of total GPU memory to run this 11 billion model. So if you have, for instance, two of them, you can load them using this command here, and then you can interact with it in a more straightforward syntax, and play around with it that way.
Great, thank you. Thanks, Oliver. So I'm going to start. That's the material we have, and take questions. There's a number of great questions in the chat. So let me just address some of those. And Seth, feel free.
Let me just interject that if anyone
yes,
wants to ask a question by audio, if you use the raise hand feature, then I will enable you to speak.
That sounds great, and I'll give priority to the audio questions. So, and yeah, Seth, please interrupt me. Oh, and there's a question from Marco. Marco, go ahead.
Hi, Peter. So one question: how much pre-processing of this web corpus are you performing? Right. So I guess you must introduce a little bit of a structure in the text to extract these fragments of knowledge. Otherwise, probably you wouldn't be able to perform reasoning, right? And kind of follow-up question would be, would like psych KB type of fragments of knowledge, would this enhance common sense type of rules, right? Would this enhance like performance, or do you use already things like this, right?
Yeah, no, that's a great question. We actually don't extract any structure from the text. So this is one of the most remarkable things about modern language models. I mean, the nearest to structure we extract would be, here is a passage, and here is the answer, and here is the explanation string. So so the basic representational unit here is a sentence. And I should say, you know, I spent 20 years in AI working with structured knowledge bases, and so, you know, the motivation for using structured knowledge bases was that at that time AI systems, they could absorb text, but they couldn't do anything with it. And one of the remarkable things about neural systems is they seem to be able to do, you know, certain amounts of things with language in its native form. Now, I should say the new work I mentioned at the end here, where we're trying to generate a coherent chain of reasoning, we are adding some degree of structure, namely a graph of connections between the sentences. So I'll say, you know, plants perform photosynthesis, photosynthesis produces oxygen, therefore plants produce oxygen. But again, so we've created that structure, but the basic unit there is still sentences. And it's quite remarkable that it's possible to do that. So we haven't imported psych, and I guess my feeling is most of the knowledge that has been entered into psych is largely available in textual form anyway, and at least, you know, from our experiments, Macaw at least is able to do something sensible with it in its native form. So it is that is a great question. I think there's an interesting issue, but perhaps one of the interesting issues going forward in AI and natural language, which is what is the appropriate relationship between neural systems and structured representations of knowledge. And different groups are placing different bets on this. So, you know, the extreme case says, well, it should all be just neural systems. The other case says, well, we need to go back to formal logic and structured representations. In our group at Aristo, I think we take something of a kind of middle ground here, which is that we do need some notion of, structured relationships between facts, but the basic unit of representation of those facts could still be sentences. As I say, we're exploring this middle ground here to pursue that.
Thanks.
Great question. And I'll read one of the online questions. Could you have used an evolvable common sense knowledge graph as part of the online learning and reasoning for formulations of question answer explanation in addition to the T5 training? Yes, I think that would be certainly another way of amplifying the training signal. The only caution I would have is that the kind of questions and answers that common sense knowledge graphs can handle tend to be fairly simple structures, like, where was X born, or what is the birthplace of Y, or does X work for company Y? So there's a risk of biasing the system too much to those kind of shorter questions. We'd like the system also to be handle these much more complicated questions, including these multi-sentence questions, like these story questions that I showed earlier. Harriet, do you want to ask a question?
Hello, can you hear me?
I can hear you. Go ahead.
So thanks for the great talk. Very interesting work. I would like to ask, how can we make, or what are the directions to make a model like Macaw smaller, but keeping the performance? Because right now this 11 billion parameter is quite large compared to BERT, for example, BERT-based. So how can we reduce the model, keeping the performance?
Let me pass that to Oyvind. He'll be able to answer that better than me.
Yeah, that is of course a really good question, and I think there's a lot of efforts in various sort of distilling methods for reducing the footprint of these models while retaining the model. For instance, you have the 11 billion model as sort of a teacher for a smaller model, which then can sort of inherit some of the sort of the internal signals of the bigger models while using less parameters at the end of the day. So I think there's a lot of potential there. We haven't ourselves invested in specifically distilling Macaw 11 billion into like a smaller model, but I wouldn't be surprised if some of these sort of techniques that are out there would be quite effective to do so, and it would be an interesting thing to do if one has a sort of an application in mind that would really benefit from that lower footprint. So I think it's definitely possible, but we have the smaller models available, small as in the Macaw large with 700 million parameters, but it's notably worse as well in terms of performance, and so that sort of naive way of doing it is not good. But using the 11 billion model as some sort of teacher for a smaller model could potentially work.
Yeah, great question.
Seth here. We can keep going for another 12 or 13 minutes, but I want to thank everyone who has joined us who can't stay that long. And once again, if you want to ask a question live, use raise hand. Sorry for the interruption.
No, that's fine. Yes, and just stop us at the appropriate moment, Seth, as well. Let me just take another question off the chat. How could we extend the knowledge base? So this is a really good question as well. So as a couple of those answers I demoed showed, the system is stuck in well, it doesn't even know quite what year it is, but it doesn't have any modern knowledge about the world. And also there are gaps in its knowledge as well. I think the way, so there's two ways of extending the knowledge. One is to do more pre-training on, maybe use a more recent T5 model to put knowledge in. The other way, which we're very interested in, as I kind of hinted at recently, is adding in a memory on top of Macaw or whatever language module you're using, essentially a large text corpus which can be updated and maintained. And the idea when a system answers a question with this external memory is it's partly using all that common sense that it's acquired through pre-training, but also can use some of the knowledge in that text corpus that essentially reads at runtime and uses to answer questions and combines the two. So there's a lot of interest now in this so-called mixture of parametric and non-parametric models, which has a lot of potential both for reducing the size of the actual language model that's used and also for maintenance and to some degree provenance of being able to track why a system came up with a particular answer. So super exciting area.
We have a question from Mayank.
Mayank, go ahead.
Yeah, so I wanted to ask, like in the presentation, I could see like during probing and during kind of trying out different stuff, you did try like a couple of linguistic properties as well. I could see some model like we mentioned, right, where we if we negate the question, the model still somehow was able to answer correctly. So I was wondering if you did any further closer analysis on if this model can kind of acquired any specific linguistic property or like mastered or like completely blew up with some of the other properties too. Grammar, I think more or less every model does well, but in terms of semantic representations, do we have any insights there?
Yeah, that's a great question as well. So we haven't done any systematic studies on Macaw. The part of the work on Macaw and the other areas we've worked on came from a systematic study of the Aristo system that we worked on earlier. So there's a paper we published on I think it's called From F to A on the science exams on the Aristo system, where we studied different linguistic and reasoning capabilities of the Aristo system. You know, could it handle negation? Could it handle could it reason with rules and so on? And we found to some extent it did have some general language handling capabilities. Offhand, I couldn't give you an exact list of things it struggles with. I know negation is something it sometimes struggles with, and sometimes complex multi-clause sentences it will have trouble with. Loivind, are there any things come to your mind that it either does well or struggles with in terms of grammar and semantics?
No, I think the main thing is if you put some complicated negation in the question, it could go wrong. It sometimes will pick it up and sometimes it will not, and that's largely an effect of the sort of the natural questions people ask that are in our data sets. They don't have a lot of sort of, oh, let me try to trick you with a couple of nots there. What is not a good thing kind of thing. So I think it has some weaknesses there if you really go after it. Partly because of the kinds of things it's used to seeing. But yeah, I don't know of specific things, but it is a good question of what are sort of the weaknesses that remain in these at the sort of the grammatical level.
Yeah, I mean that would be a great area of study for somebody who'd be interested. I'll just pull another question out of the chat here. Can you comment on the explainability of the answer about the mixed fruit juices? It would make you sick. So I would say the explanation facility in Macaw is somewhat frustrating, and it's the reason we've moved on to our entailment writer system. So so in that example, I asked if I mix two fruit juices, the system said it would make you sick. As an explanation, actually, did it give an explanation? It didn't give an explanation. I could ask it for an explanation. I'm just going to see if I can. Let me see if I can reproduce that example here. So I'm just looking back through my notes here to find it. Here we go. I'm not sure I can completely reproduce it grammatically, as I have an abbreviated one in my notes. You drink it, what happens next? And we'll see what it says here. So this shortened version says it tastes like grapes, which is a better answer. If two substances together form a solution, then those substances will react chemically. Let me just find the original version of this, which is a slightly more worded. More wordy version. I'm not sure if I can find it off the fly. As you can see, this demonstrates its answers are a little bit flawed here. Let me make the point I wanted to make. The system gives an explanation, but this doesn't really reflect anything about what it did. And in fact, sometimes the explanation can be supporting a different answer to the one it produces. You know, we call this an explanation. It's really sentences that are relevant to the answer that we're given, that's been given. What we really would like is an explanation which has two additional properties. First of all, it should be an explanation which really is a valid chain of reasoning to produce the answer. In other words, if I believe the sentences in the explanation, I should believe the final answer. And secondly, the explanation should contain sentences that the model itself actually believes. So if I asked, you know, do you believe if two substances together form a solution, then those substances will react? The system should say yes. So those two properties are not properties of Macaw, but they are properties of our new entailment writer system that we're working on.
By the way, if you go back to the repository page and click on the examples link, either
I can grab it. I can grab
it from there, and that's I like this page because it shows you can search for grape juice on that page. But
sure,
this is a fun place to go and see what multiple different models will say to these different these different questions.
All right, let's put in the full verbatim version. All right, so it says you get sick. And here's this explanation. If two substances form a solution, that's not great. The solution is formed. If something is soluble, then something can be dissolved. So there's nothing about being sick. So this is a good example of a bad explanation that really doesn't entail the answer that's being given here. I mean, I could say, well, I could ask, well, you know, why would I get sick? And it would try and make something up about that. Somebody else asks, Macaw couldn't fill a truth table. Is that correct? Well, you'd have to fill a truth table by asking questions one by one, if that's the intent. So you could fill it in that particular way. Another question: what would happen if you included contradictory information in the training set? Well, that's a really good question. In fact, there's a ton of contradictory information in the training set. So both the pre-training of T5 contains all sorts of conflicting information on the web. And of course, there's some degrees of approximation and that are present in statements that are given. So for instance, the statement, magnets attract metals, it's sort of true. Magnets, and for some levels of reasoning, that's true. But of course, there are exceptions. Some metals are not attracted. Macaw will tell you birds fly, but of course, penguins don't fly. It contains and tries to manage the best it can a lot of apparently conflicting information in it, and tries to do so the best it can.
Question from Stephen live.
Awesome, Stephen, go ahead.
Yeah, hi. Yeah, thanks a bunch for the talk. It's excellent. I was just typing this, and I'll read it. Can you trick it, like if you say you pour yourself a glass of water, then you absent-mindedly pour it from a different glass of water you drink, this is what happens. I'm wondering about the explainability, like how far you can get it to give the wrong answer that it'll poison you. It's kind of linguistic tricking. Like if I say this is a different glass of water, or this is dihydrogen monoxide, or this is a naturally occurring substance.
I see.
By distilling cactus or something. It's kind of linguistically getting tricked, or is it that the underlying knowledge base isn't, the underlying explainability isn't really very good?
Yeah, I think that's true. And in this case, I mean, the thing which is strange here is when I asked the abbreviated question, it gave a reasonable answer. So if if you remove this peripheral information about it looks okay, I try sniffing it, but I have a bad cold. If I take out that shouldn't really affect the answer. And also whether I'm thirsty, that shouldn't affect the answer. So
well, you could ask it. I'm really I'm in a canoe. I'm in the middle of the ocean. I'm really thirsty. I'm going to die. Can I drink seawater? That's actually a good non-trivial. And how much?
All right. In the ocean, I am really thirsty. Can I drink seawater? Was that like this?
Yeah. Or
see what it says. It says yes, but only if it's boils. So that's a good answer.
No, well, that's a context fail, though. I mean, that's assuming you don't have a kettle in your boat.
Yeah. Animals usually can't drink salt water. Salt water contains sodium chloride, and then if something dissolves then in something else, then that something can be drunk. So,
right, but it doesn't get the context. Like if you say I'm in a kayak.
I see. Oh, I see. Can I drink the? I see. Can I drink the water around me? So here it should realize there's seawater. No, it's salt water. If I am kayaking on a lake.
I guess if you say like, what's my life expectancy if I don't drink is like whatever 12 hours. What's my life expectancy if I do drink the seawater?
Right. Oh, here it's giving a good answer. Yes, if it's not salty. So it's got some notion.
Can I interject that I learned long ago that if you demo a system to someone, then people tend to think that it is fully functional and impervious to errors and all of that kind of stuff because it looks good and it just looks really promising. Why don't Peter and Ivan, why don't you take one more question and then we should wrap up. You've been going for over an hour and a quarter, so why don't you take another question?
Right. I should ask, are there any other live questions? If not, I'll just grab one or we'll make some closing comments.
The Elon Musk
I just enabled Jeff Barone. I think that'll be last.
Okay,
sure.
Jeff, go ahead.
So just a quick observation, I think, to check with you, and then a question, which is, it seems like if the exact same question is asked, is that true?
Sorry, you cut out for a second. If the exact same question is asked,
will it always give the exact same response? And then also another question about feedback.
So in its default setting, yes, it will give the same response. But we have another setting where instead of picking the most preferred answer, it can sample from alternative answers, in which case we do get non-deterministic behavior. So there's techniques for getting essentially it's like not top choice answer, and we use that sometimes if we want to get a collection of answers to assess. And then you had a question about feedback.
Like, do you have any mechanism for people to give feedback on the appropriateness of the answers?
Not we don't have any, so we don't have a live interactive version set up. That certainly would be a good thing to do in order to try and collect additional data if we wanted to collect more good training examples. That would be a great suggestion. Yeah, currently, if you want to use the live system, you need to use it through the Hugging Face, the Hugging Face library. As I say, you can browse the system's answers so far, but we have decided not to support a live demo, both for manageability and also because of its potential for generating toxic or biased content. Great, so I'll stop there and pass back to Seth. Seth, you're muted.
I should know better by now. We should all know better. Thank you, Peter and Oyvind. That was fantastic. You had great engagement there, which is the mark of a good presentation. If you, in a way, if you raise more questions, then you could have kept going for quite a long time, and people clearly would love to have the ability to kick the tires here. So I did put in the chat the address of the demo version that you mentioned online, and I saw that Alan AI has a bunch of other system demos out there that'll give people things to play with if they wish to. So thanks very much for the presentation. As I said in the chat and previously, we'll post video after Zoom has finished processing it. And stay tuned for a next session. We don't have one scheduled yet, but as I said at the beginning, if anyone in the audience would like to give a presentation, just drop me an email message or message me over the Meetup platform, and we'll see what we can arrange. So thanks very much to our speakers today, and I really enjoyed the presentation, and see everyone who's attending next time, I hope.
Yeah, and thanks for inviting us. Thanks for the engagement and the great questions from everybody. It was a pleasure to talk to you.
Thank you.
Ciao.